Hello, my name is Daniel, and today we will be going through the AMC 12B from the year 2008, and let's get started. First problem, a basketball player made 5 baskets during a game. Each basket was worth either 2 or 3 points. How many different numbers could represent the total number of points scored by the player? Okay, so the minimum number of points is 2, 2, 2, 2, 2, so that would be 10. And the maximum would be 3, 3, 3, 3, 3, which is 15, right? And so there are 6 numbers from 10 to 15, including these two, so it's 6, it's E. Number 2, a 4x4 block of calendar dates is shown. The order of the numbers in the second row is to be reversed. Then the order of the numbers in the fourth row is to be reversed. Finally, the numbers on each diagonal are to be added. What will be the positive difference between the two diagonal sums? Okay, so since we're only looking at these two diagonals, if the order of this and this, those are changed, then we can just focus on those two and these two, right? So that will give us 9 will become 10, 10 will become 9, 22 will become 25, and 25 will become 22. So we want the difference between the two sums. So those sums are going to be 1, 10, 17, 22, right? So that's 1, 10, 17, 22, and 4, 9, 16, 25, right? And 4, 9, 16, 25. These two are going to give a difference of 6, and then these two are going to negate that difference by 2, so this is equal to 4. That's the answer, it's B. Number 3, a semi-pro baseball league has teams with 21 players each. League rules state that a player must be paid at least $15,000, and that the total of all player salaries for each team cannot exceed $700,000. What is the maximum possible salary in dollars for a single player? Okay, so to give the maximum for one player, that means we need to give all the others the minimum, right? So since we have 21 total, then we will have to give 20 players the minimum amount. So that's 700,000. That's the maximum total, minus the minimum for all 20, minus 15,000 times 20. So this is equal to 700,000 minus 300,000. So this is going to be equal to 400,000. Right? So that's our answer. It's C. Number 4, on circle O, points C and D are on the same side of diameter AB. Angle AOC equals 30 and angle DOB equals 45. What is the ratio of the area of the smaller sector COD to the area of the circle? Okay, so since we know that this whole thing is 180, that means we know that angle, and this angle is going to be 180 minus 30 minus 45. That's just 105, right? So it's 105 degrees. So it's going to be 105 degrees all over 360, and so this is going to be equal to 21 over 72, which is equal to 7 over 24, right? So this is the answer, it's D. Number 5, a class collects $50 to buy flowers for a classmate who is in the hospital. Roses cost $3 each, and carnations cost $2 each. No other flowers are to be used. How many different bouquets could be purchased for exactly $50? Okay, so we have some number of roses and some number of carnations. Since carnations cost $2 each, then we can just exactly match $50 with 25 carnations, right? And 0 roses. But then since roses are 3 and carnations are 2, that means carnations will decrease by 3 and roses will increase by 2, like that, right? Right. So we have 2 and 19, and so we have 4 and 19 and 6 and 16 all the way up to, then the maximum number of roses would be 16, right? Because that's 48, so we have plus 2 left, which is 1 carnation, right? And so we want to know the number of numbers from 0 to 16, right? So 0 to 4, 6, all the way to 16, so this is from 0, 1, 2, 3, all the way to 8 if you divide by 2. So this is 8 numbers, including 0, that's 9, so it's 9, it's C. Number 6, Postman Pete has a pedometer to count his steps. The pedometer records up to 99999 steps, then flips over to 00000 on the next step. Pete plans to determine his mileage for a year. On January 1st, Pete sets the pedometer to 00000. During the year, the pedometer flips 44 times. On December 31, the pedometer reads 50,000. Pete takes 1,800 steps per mile. Which of the following is closest to the number of miles Pete walked during the year? Okay, so since it flipped 44 times, that means the number of steps, that is equal to 100,000 times 44, right? Because it flipped 44 times, and then plus it read 50,000, so plus 50,000 more. This is going to be equal to 50,000, and so we have to divide that by 1,800, right? So 4,450,000. Yeah, this is gonna be divided by 1,800, right? So these zeros are going to cancel, and so that's going to be 44500 over 18, which is equal to 2,500, right? So this is the answer, it's A. Number 7, for real numbers a and b, define $8 b equals a minus b squared, what is x minus y squared dollar y minus x squared. Okay, so we know that these two are just exactly the same thing, right? And so if we have a minus b squared, then that's just gonna be 0 squared, right? So it's 0, it's a. Number 8, points B and C lie on AD. The length of AB is 4 times the length of BD, and the length of AC is 9 times the length of CD. The length of BC is what fraction of the length of AD? Okay, so we have AD, and if we have B like that, yeah, then we're gonna have 4 to 1, and if we have C, then we're gonna have 9 to 1, right? So that's 9 to 1. So this sum is so that sum is 10, and this sum is 5. So that means we're going to have not 4 and 1, but 8 and 2, right? So that will make the sum the same. And so that means just BC, this length is going to be 2 minus 1. That's going to be 2 minus 1, which is 1. So this length is 1. And BC is what fraction of AD? And we see that the whole of AD has 10, right? So it's 1 over 10 equals, just that's the answer. It's 1 over 10. It's C. Problem number 9. Point A and B are on a circle of radius 5 and AB equals 6. Point C is the midpoint of the minor arc AB. What is the length of the line segment AC? Okay, so first let's say that our circle is this one. Okay, so we have that circle, and we have points A, B, and C on that circle, right? So those points would connect to look something like this, like that, right? So if we say that this is our center, right? That's our center, and this is A, and this is B, and this is C. Since the radius is 5, that means this length is 5. And since AB equals 6, but then C is bisecting this. That means this much and this much is 3 each. So it's 3 and it's 3. And since this is a right angle, by the Pythagorean theorem, we know that this, that much length, that's equal to 4, right? So this is 4. But then since this whole thing, that's just a diameter, and we know this is 4, right? So this is 5 minus 4, so this much, so this much, that would equal 1, right? So that is 1. And we want the length of AC, and so if we get so if we connect AC, so if we connect to AC, then that's going to be 3 and 1 and AC, right? So that's going to be 3, 1 AC with this right angle. So AC is equal to the root of 3 squared plus 1 squared, which equals root 10. So root 10, that's the answer. It's A. Problem number 10. Bricklayer Brenda would take 9 hours to build a chimney alone, and bricklayer Brandon would take 10 hours to build it alone. When they work together, they talk a lot, and their combined output is decreased by 10 bricks per hour. Working together, they build the chimney in 5 hours. How many bricks are in the chimney? If we say that X bricks are in the chimney, they build it in 5 hours, right? So each hour, they did X over 5 amount of work. But then bricklayer Brenda took 9 hours alone, so that's X over 9. Plus, Brandon take 10 hours to build it alone, so that's X over 10. But their combined output is decreased by 10 bricks per hour, so this is minus 10, right? So multiplying 90 to everything, that means 18x equals 10x plus 9 minus 900, right? Plus 9x minus 900. So if 18x comes that way, that means x equals 900. So that's our answer. It's 900 bricks. It's B. Number 11. A cone-shaped mountain has its base on the ocean floor and has a height of 8,000 feet. The top 1 over 8 of the volume of the mountain is above water. What is the depth of the ocean at the base of the mountain in feet? Okay, so since it's cone-shaped, then if the volume ratio is 1 over 8, volume 1 to 8, right? Then that means the length ratio, that's just the cube root of each of these, right? So that's the cube root of 1, which is 1, and the cube root of 8, which is 2, right? So that means the height above water, that will be 1/2 of the whole thing, which is 8,000, 1/2 of 8,000. So this is going to be 4,000, right? And so the depth of the ocean at the base of the mountain, that's going to be 8,000 minus 4,000, which equals 4,000. So 4,000 is going to be our answer. It's A. Number 12. For each positive integer n, what is the mean of the first n terms of a sequence is 1. What is the 2008th term of the sequence? Okay, so since the mean of the first n terms is n, this basically means that the sum of first n terms, this equals n squared, right? And if the sum is n squared, that means that the sequence is on numbers. And so this is going to look like 2n minus 1, right? And so what is the 2008 term? That gives us, we have to just plug 2008 into n. So 2 times 2008 minus 1, this equals 4016 minus 1, which is 4015, right? So 4015 is our answer, it's B. Number 13, vertex E of equilateral triangle ABE is in the interior of unit square ABCD. Let R be the region consisting of all points inside ABCD and outside ABE whose distance from AD is between 1/3 and 2/3. What is the area of R? Okay, so if we bring this out like that, then we would have, so this is A and this is B, this is C and this would be D, right? And so we want the distance from AD to be between 1/3 and 2/3, and so those lengths would be 1/3 will be over here, and 2/3 will be like over here, like that. If we move this a little bit closer, then that will be more accurate, like that, right? So this is 1/3, this is 2/3, and so we want this area, right? So we want that total area. So since this is E, right? Since that's E, then this area that we want will be this whole thing, that whole thing, minus this, plus this, right? And so this whole thing is just 1/3 of the all thing, right? And it's a unit square, and so the area, yeah, so this much is equal to 1/3, which is this much, that's 1/3, and then minus this much, right? Minus, and then we have √3/4 times, and then this is 1 unit, and this is 1/3, so if we draw a line like that, right, then this would also be an equilateral triangle, so this is 1/2. Sorry, that's 1/3, right? So that's 1/3, and so times 1/3 squared, and then this, and the minus this much more, so that's 1/3 times, and then since this is also 1/3, that means this is √3/3, and so since this is also 1/3, that means this whole thing, that is √3/9, right? And so this means that it's 1/3 minus 36 minus √3/36 minus √3/9. This equals 1/3 minus 5√3/36. This is 12 minus 5√3/36, right? And so this is our answer, it's B. Number 14, a circle has a radius of log 10 of a squared and a circumference of log 10 of b to the 4th power. What is log a to the b, right? So this is 2 log a, this is radius, and this is the circumference, right? So that's 4 log b, and that's the circumference, which is 2 pi r, and since this is r, if we just plug that in, that's 2 pi times 2 log a, right? And so if we cross out 2, 2, and 4, that gives us log b equals pi log a, right? So log a of b, that's log b over log a, which is log a under pi log a, right? So it's pi log a. So these two cancel, this is pi, right? So this is the answer, it's C. Number 15, on each side of a unit square, an equilateral triangle of side length 1 is constructed. On each new side of each equilateral triangle, another equilateral triangle of side length 1 is constructed. The interiors of the square and the 12 triangles have no points in common. Let R be the region formed by the union of the square and all the triangles, and S be the smallest convex polygon that contains R. What is the area of the region that is inside S but outside R? Okay, so if we bring out a diagram of this, then it looks like this. And so we will need to find the distance of these 4 areas, right? And so because this octagon, that's the smallest convex polygon containing R, and so since this is 1 and this is 1, and so that's also 1, this is also 1, that means this is also 1, right? So this is 1 and this is also 1. And let's say this is x degrees, right? And so that means the area of one of these triangles will be 1 squared times 1 times 1 times sine x, right? 1 times 1 times sine x, right? And so 4 of these, that would just be the whole thing times 4, right? So it'd be this times 4. So this would be 2 sine x, right? And so now all we have to know is find the value of x, and then we are finished. So that's very easy, because if we see here, then this whole thing is 360, right? So this is 360. So x is equal to 360 minus 90 minus 4 of these 60 degrees, right? Minus 4 times 60. This equals 120 minus 90 equals 30 degrees, right? And so x equals 30 degrees. this equals 2 sine 30 degrees, and this equals 2 times 1 over 2, which is 1. And that's the answer. It's C. Number 16, a rectangular floor measures a by b feet where a and b are positive integers with b is greater than a. An artist paints a rectangle on the floor with the sides of the rectangle parallel to the sides of the floor. The unpainted part of the floor forms a border of width 1 foot around the painted rectangle and occupies half the area of the entire floor. How many possibilities are there for the ordered pair a, b? Okay, so we're going to have something like this, right? A and b is going to be greater than a, and so inside that we're going to have the painted floor, and then the border is with 1 foot, so this is 1 foot, this is 1 foot, this is 1 foot, this is 1 foot, and that means that this part that's going to be a minus 2, and this part that's going to be b minus 2, right? This is going to be b minus 2, and so we want the possibilities for the a, b, but then the border occupies half the area of the entire floor, right? And so that means this one, that also occupies half of the whole thing, and so half of AB is equal to a minus 2 times b minus 2, right? And so AB equals 2 times AB minus 2a minus 2b plus 4, and so AB equals 2ab minus 4a minus 4b, minus 4b, and then plus 8, and so this gives us that AB minus 4b minus 4a, like that, plus 8, right? So this gives us a minus 4 times b minus 4 equals 8. And so here this gives us this gives us this and this. They can be either 1 and 8 or 2 and 4, right? Because b is greater than a. And so these are the only two possibilities, right? So we have two possibilities. So that's the answer. It's B. Number 17, let A, B, and C be three distinct points in the graph of y equals x squared, such that the line AB is parallel to the x-axis and ABC is a right triangle with area 2008. What is the sum of the digits of the y coordinate of C? Okay, so first, if we bring out a diagram of this thing, then that would look something like this, right? And so if we have points A, B, and C like this and like this, right? So let's say this is A and this is that's B, right? And then AB is parallel to the x-axis and ABC is a right triangle with area 2008. So C must be somewhere like that, right? But then since this is a right triangle, that means there must be a circle that goes in there. And so to make this better, let's actually bring in the circle like that, and then if we make the diameter equal to the length, right? So that's going to be our diameter like that, right? And then a little bit more down like that, right? And so that's going to be our diameter. So this is A and this is B, right? So let's call this point, so let's call this point A. So the y would be a squared, and so this one, that would be negative a. Also, this would be the other point, and so that's C. So this is C, this is C, right? And so like that, right? And so this would be right angled and this would be C, and let's say C is C comma C squared, right? So basically the only thing that we need to notice is that here A is the radius, right? So that's much is A, and so if we draw a line from here to there, so from the center to there, then this would also be A, right? And if we draw a line from here to right there, right? So this would be C, and so that means this length is C, and this length, that will be a squared minus C squared, right? So this is a squared minus C squared, and so if you, that's the right triangle. So if we use the Pythagorean theorem like this, alright, so that will become a squared minus C squared. So a squared minus C squared, that's this. That is the root of that. So this is root a squared minus C squared, and so that means a squared minus C squared equals 1, right? Because because if we both divide by root a minus C squared, root a squared minus C squared, and so this is what it's going to give us. And then here, since the area is 2008, then we know that 2a times this much, right? So 2a times a squared minus C squared, 2a times a squared minus C squared times 1/2. That's the area of the triangle. That's 2008, right? And so since this is 1, so since these two cancel and this is 1, that means A equals 2008, right? And since a equals 2008, if we put that in here, that means c squared equals a squared minus 1, which is 2008 squared minus 1, right? So this is 4032064 minus 1, so that would be 063. And so if we want to add the sum of the digits, right? So if we take the sum of the digits, that's going to be 4 plus 3 plus 2 plus 6 plus 3, and so that's going to give us 18. So this is our answer. It's 18. It's C. Number 18. A pyramid has a square base ABCD and a vertex E. The area of square ABCD is 196, and the areas of AB, E, and CDE are 105 and 91 respectively. What is the volume of this pyramid? Okay, so if we bring out the pyramid, so this is what our pyramid looks like, and let's say that this is E, right? And so this would be A, B, C, and over here that at the back would be D, right? And from E to the midpoint of AB, right? From E to the midpoint of AB, this would be the line, and then from E to the midpoint of CD, that would be one more line, right? And so the area is 196, right? So that means each length, that is 14, right? So this is 14, this is 14, right? And then the areas of ABE and CDE are 105 and 91, right? And so that means that area is equal to this times 1/2, which is just this times this, right? So since this is 7, then this would be 105 divided by 7, right? And so this is going to be equal to 15. Same thing for here. That is like a right angle right there. So this is going to be this times 1/2, which is 7 times this much. And so this is going to similarly be equal to 91 divided by 7. This is equal to 13, right? So we have this much is 15 and this much is 13. So let's write that down. This is 15 and this is 13, right? And so now if we connect to the bottom parts, then that would just be 14 because it's just this much, right? And so if we take that out, so that would be like that, and this is 15, 13, and 14, right? And then the height of the pyramid, that would be that length, right? And so if you see here, then since we have 15 and 13, then we can think about 9, 5, right? So that would give this a Pythagorean triple, so this would become 12, and that would also be congruent with this one, right? So the height is 12. Height is 12, and so the volume is equal to 1/3 times base times height, which is 1/3 times base, which is 196. 196 times height, 12. This is 196 times 4, which is 784, right? So 784 is the answer. It's E. Number 19, a function f is defined by fz equals 4 plus I z squared plus alpha z plus gamma for all complex numbers z, where alpha and gamma are complex numbers and I squared equals -1. Suppose that f1 and fi are both real. What is the smallest possible value of the absolute value of alpha plus the absolute value of gamma? Okay, so let's call alpha is equal to ai plus b, and let's say gamma is equal to xi plus y, right? So f1 and fi, they're both real, so if you just put them in, then it's going to be f1, this is equal to 4 plus I plus alpha plus gamma, which is going to be equal to, that's going to be equal to 4 plus b plus y plus 1 plus a plus xi, right? And then fi, this is going to be equal to, that's going to be equal to -4 minus I plus alpha I plus gamma, and that's going to be equal to -4 minus a minus y, and then plus b plus x minus 1 I, right? And so since they are both real, that means this part and this part, they're both 0. So this gives us that 1 plus a plus x equals 0, and -1 plus b plus x equals 0. And so the minimum of this, so the minimum that will become when x is equal to 0, and so a is going to be -1 and b is going to be equal to 1. And y, there's no really restriction here, so just y can just equal 0, that can be the minimum, right? And so that will give us 0, 0, and -1, 1, so that's, so this much would be equal to root 1 squared plus 1 squared plus root 0, so that's going to be root 2, so root 2 is the answer. It's B. Number 20, Michael walks at the rate of 5 feet per second on a long straight path. Trash pails are located every 200 feet along the path. A garbage truck travels at least 10 feet per second in the same direction as Michael and stops for 30 seconds at each pail. As Michael passes a pail, he notices the truck ahead of him just leaving the next pail. How many times will Michael and the truck meet? Okay, so if we have the path like this, we have Michael here, and we have the garbage truck there, and then we have trash pails every 200 feet, like that, right? Since the truck travels at 10 feet per second, but then the pails are located every 200 feet, right? So this means that truck will take 20 seconds to get to next pail. Yeah, to get to the next pail, right? Yeah, since the truck travels at 10 feet per second, and Michael walks at 5 feet per second, right? That means when the truck is moving, then the truck gains by 5 feet per second, right? But then it's but then it goes 20 seconds, right? So it gains by 100 feet, right? And then when the truck doesn't move, then Michael gains on the truck, gains by 5 feet per second, right? Because the truck is just staying still, so that's 5 feet per second, right? But then it stops for 30 seconds at each pail, so this is 5. So that's 5 times 30, which is 150 feet. 150 feet, right? And so now if we put a distance and time graph, right? Time table, right? Then at the first meeting, he notices the truck ahead of him just leaving, right? So so their distance between them right now, this is 200 feet, right? 200 feet. 20 seconds later, right, because then this will be moving and Michael will also be moving. Then when the truck is moving, then the truck gains by 100 feet, right? So their distance will increase by 100 feet, which is 300 feet, right? And then after 30 seconds, because the truck has stopped, Michael gains 150 feet, so that will be 150. And then 20 seconds later, then their distance will increase by 100 feet, so that's going to be 250 feet, and so on, until they get 0. First time, right? So it's like the truck will be going somewhere, and then the Michael will also be walking, and then they will be at the same location, right? And so if we start over from that part, right? If we start over from there, because that's just their first meeting, right? So their distance is 0, right? Let's just move these back to the beginning, right? So this is back to the beginning. This time, 20 seconds are passing, right? So the truck is moving. The truck gains by 100 feet, so this becomes 100. But then next, Michael gains 150 feet, so it's negative 50, right? And then 100 more feet are added, so that becomes 50. And then 150 feet are subtracted, so that's minus 100, minus 100. And then 100 feet are added, so that's 0. And then it's minus 150. And then the next plus 100, that becomes minus 50, right? So after this, it's all going to be negative values. And so that means that the number of intersections, so the number of meetings, is just within these. And so from this 0, we have 1 meeting. And between 100 and negative 50, we will have 1 more 0, so that's 1 more. And between these two, we will have 1 more. Between those two, we will have 1 more. And then this one, that will be the last one. So we have 5 meetings in total. So the answer is 5, it's B. Number 21, 2 circles of radius 1 are to be constructed as follows. The center of circle A is chosen uniformly and at random from the line segment joining 0, 0 and 2, 0. The center of circle B is chosen uniformly and at random and independently of the first choice from the line segments joining 0, 1 to 2, 1. What is the probability that circles A and B intersect? Okay, so if we have those 2 circles, right, then we are going to have 1 have 2 and 1, and so yeah, so 1 is going to be moving along this line as the center, and then 1 more is going to be moving along that line as the center. So it can be like this circle and this circle, right? Or they can intersect like that circle and that circle. Those will intersect, right? And so we want the probability that they will intersect. And so they will intersect if the distance between their centers, if distance is less than 2, right? Because they both have the radius of 1, and so their distance between AB has to be less than 2, right? And so that means that their x values difference have to be less than root 3, right? Because they are 1 apart, and so if they are 2 apart diagonally, then and they are 1 apart vertically, that means they are root 3 apart horizontally, and so the x values have to just be less than root 3, right? And so this just means that the absolute value of ax minus bx, right, this is the x value of a, and this is the x value of b, this is less than root 3. And so we can draw like a square diagram like that, right? Something like that. And so we can say that this side is a's x value, and this side is b's x value. B's x value, and their minimum is 0, and their maximum is 2, right? And their difference has to be less than 3, and so if we graph that, then that's just going to be right here, those two triangles, like that and like that. And so this is going to be root 3, this is also going to be root 3, and the area that they do intersect, that's going to be this middle area, right? And so this area is going to be the whole thing, which is just 2 squared, which is 4, minus, and then these two triangles, right? And so that's just 1 of this square, 1 square, minus 2 minus root 3, 2 minus root 3 squared, right? And so this is going to be equal to, we want the probability, so this all has to be over 4. So this is all over 4, and then 4 minus, and then that's going to be 7 minus 4 root 3. This is equal to 4 root 3 minus 3 over 4, right? So this is the answer. It's E. Number 22. A parking lot has 16 spaces in a row. 12 cars arrive, each of which requires 1 parking space, and their drivers choose spaces at random from among the available spaces. Auntie M then arrives in her SUV, which requires 2 adjacent spaces. What is the probability that she is able to park? First, let's get the probability that she is unable to park. That will be when there are no double space between all those 12 cars, right? Since we have 12 cars like that, we want to choose slots where the 4 vacant spaces will go in like that, right? So that will be, we have 13 spaces, and then we will choose 4 of them. So this is going to be 13 choose 4. Total number of possibilities is there are 16 spaces, right? And from their 16 spaces, then we just need 4 vacant spots, right? 4 vacant spots for the vacant spots to be. So that's just 16 choose 4, 16 choose 4, right? And so the total probability is going to be 1 minus being unable to park, which is 13 choose 4, over 16 choose 4, 13 choose 4 over 16 choose 4, right? And so this means that there's 1 minus, and then 13 times 12 times 11 times 10 over 16, 15, 14, 13, right? And so these two are going to cancel, and then 10 and 15, they're going to cancel with 3 and 2, and 12 and 3 are going to cancel with 4, 4, 2, and 16 are going to cancel with 2, 14 is going to cancel with, 14 is not going to cancel. So this is all going to be equal to 1 minus 2 times 14 under 11, and so that is 11 over 28. This is 17 over 28, right? So this is the answer. It's E. Number 23. The sum of the base 10 logarithms of the divisors of 10 to the nth power is 792. What is n? Okay, so since 10 to the nth power, this is 2 to the nth power times 5 to the nth power. That means there are n plus 1 times n plus 1, which is n plus 1 squared, divisors in total, right? And since the base 10 logarithms of the divisors, their sum, so if we say that the divisors are a1, a2, a1, a2, a3, a4, all the way, right, like that, then that's going to be log of a1 plus log of a2 plus log of a3 plus log of a4 plus all the way, right? And so this is going to be log of, and then a1 times a2 times a3 times a4, all the way like that, and this is going to be equal to 792. And so this means that the product of our divisors, so this is going to be equal to 10 to the 792 power, 10 to the 792 power, but then this is always equal to this number, which is 10 to the nth power, this times this over 2, right? n plus 1 squared over 2, right? And so that means this and this is equal. So so n times n plus 1 squared over 2 equals 792. No, equals 792, right? And so if we multiply by 2, right? Then that's going to be 792 times 2, which is 1584. And so this is equal to 11 times 12 times 12. And so that means n equals 11. And we can just get this by substituting these numbers into that, and then just seeing the ones digit, and if it's equal to 4, right? And then the only ones digit that will give this equal to 4 is 11. So that's one more way that you can find out that n is equal to 11. So the answer is A. Number 24, let A0 equal 0, 0. Distinct points A1, A2 all the way lie on the x-axis, and distinct points B1, B2 all the way lie on the graph of y equals root x. For every positive integer n, an minus 1, bn, an is an equilateral triangle. What is the least n for which the length a0, an is greater than or equal to 100? Okay, so first let's draw the coordinate plane like that, and like that. That will give us, we can bring out our root x here, like that. So if that is root x, right, then let's just try to draw two of these triangles, right, two of these equilateral triangles. So those will just be, so those are just going to be these, like that, right? So those are going to be the two triangles. And since we don't know which number these are, let's say this is, let's say the height is hn, and let's say the height of this one, that is hn plus 1. So this is root x, right? And then so these are also the y values of these points, right? And so now we can just find out this length, right? Because since these are equilateral triangles, that means it's 2 to 1 to root 3. That means this is that means this one is root 3 times that length, and this length is root 3 times this length. And so the whole thing, this is going to be hn plus 1 over root 3. And so this is going to be equal to hn plus 1 squared minus hn squared, because this one that's taking into the fact that these are the y values of these points. And so this length is also the difference of these x values. And so this x value is going to be hn plus 1 squared, and this x value is going to be that's going to be hn squared, right? And this is equal to hn plus 1 plus hn times hn plus 1 minus hn, right? And so these two are going away, right? And so that means this is equal to 1 over root 3, right? So 1 over root 3 equals hn plus 1 minus hn. And so this is just the height difference. Since the height difference, this is equal to 1 over root 3, right? Then this means that the base is always going to be 2 over 3. The base is always 2 over 3 longer, right? Since we start at 0, 0, right? Start at 0, 0. So that means an, this length is going to be 2 over 3n, 0, right? And so that means a0, an, this is going to be equal to 2 over 3 times n. That's going to be 1 plus 2 plus 3 plus all the way up to n. And so this is going to be 2 over 3 times n plus 1 over 2. So these two are going to be n plus 1 over 3, right? And this is going to be greater than or equal to 100, right? Greater than or equal to 100, right? And so this means that n plus 1 is going to be greater than or equal to 300. That means the smallest n, like that, the smallest n like that is 17. That means 17 is the answer. It's C. Number 25, let ABCD be a trapezoid with AB and CD are parallel. AB equals 11, BC equals 5, CD equals 19, and DA equals 7. Bisectors of angle A and angle D meet at P, and bisectors of B and C meet at Q. What is the area of hexagon ABQCDP? Okay, so if we draw a diagram of this, then that's going to be our diagram, and we're going to have, this is going to be A, so this is going to be A, this is going to be B, this is C, and this is D, right? And AB is 11, BC equals 5, CD equals 19, and DA is 7. And bisectors of A and D, so this one, these are the bisectors, right? So they meet at P. So this is point P, and the same thing, bisectors of B and C, they meet at Q. So this is Q, right? And then we want the area of hexagon ABQCDP. That's ABQCDP, like that, right? So that area is this whole area minus this minus that, right? And so since we know that these are right triangles, that means it's just this whole length minus these, minus that and minus that, right? And so now let's set this length as x, right? If that's x, then this and this are equal, so this would also be x and this would also be x. And also same thing here, since these two are 2x, that means these two are 2x also, so this would be x2 and this is x. Same thing here, this is x. If we get the whole thing, right, a, b, q, c, d, p, this is going to be equal to the whole thing, a, b, c, d, minus ADP and BCQ, right? Minus ADP minus BQC, and this is going to be equal to, so this is 11 times 19, so that's 15. 15 times 2x, right? So that's 30. That's 30x, and then minus, this is going to be 7 over 2x, minus, and then this is going to be 5 over 2x, right? 5 over 2x. And so this is 30 minus 6 of x, which is equal to 24x, right? So this is 24x. So this is the thing that we want. And so from here, we can just draw separate lines. We can draw this line. Yeah, we can draw a line from A to CD and from B to CD, right? And let's call this length A. And since this much and this much, they are the same, that means that is 11 also, right? So this is 11. So this is 11. And this much, that is 7 squared minus 2x squared. And so this is 19 minus 11 minus a, which is 8 minus a, right? So this much, this is 8 minus a. So now, since these two triangles, those two triangles have this in common, that means 7 squared minus a squared equals 5 squared minus a squared, right? So if we write that down, 7 squared, that's 49, minus 8 minus a squared equals 5 squared minus a squared. So 5 squared equals 25, right? So it's 25 minus a squared. And so it's 49 minus 64 minus 16a plus a squared equals 25 minus a squared, right? And so we know that these two cancel. And then that gets us to 49 minus 64 plus 16a equals 25. 16a equals 64 plus 25 minus 49. And so 16a equals 40, right? A equals, so a equals 5 over 2, right? And so a equals 5 over 2. We want to get this length, right? That length, that is 2x. And so 2x is going to be equal to, so this is 2x. 2x is going to be equal to root 25 minus a squared, right? Minus 25 over 4 equal to root 25 times 3 over 4. This is 5 over 2 and then root 3, right? And so 2x equals 5 root 3 over 2. And so we want 24x. And so if we multiply by 12, right, that means 24x equals this much. So that's 5 root 3 over 2 times 12, which equals 30 root 3, right? So this is 30 root 3, it's B. So that was it for the AMC 12B from the year 2008, and thank you for watching.